Hello, mathematicians. This is 8.1, 0 and negative exponents. So 8.1, you have two properties right off the bat I want you to put in your notes. 0 as an exponent and a negative exponent. So write down 0 as an exponent. This is very easy to remember. Anytime you put anything to the 0 power, it equals 1. Now here's my quick little explanation. Exponents are your multiplying. So if I have 5 to the 0 power, it can't equal 0 because if I do 5 to the first, then it's not, I'm going to times 0 by 5 and then I would get nothing. So whenever you're multiplying, you have to start with something. You have to start with 1. And then 5 to the first power is 5. And then 5 squared is 5 times 5, which is 25. And then 5 cubed is 5 times 5 times 5, which is 125. So it's getting larger each time, and it's starting small, and then you're timesing it by 5, and then you're timesing that by 5, and that by 5, and then that by 5, and it just keeps increasing each time. So that's kind of why a lot of people don't ever understand why it's at 0, but that's kind of my little definition. Negative exponents. It's kind of the same thing. If I have a negative exponent, it doesn't become negative, it just becomes smaller. So let's go back to our 5's example. 5 to the 0 is 1. 5 to the first power is 5. 5 squared is 25. Okay? And it's multiplying by 5 each time I go up. Each time I go up, I multiply by 5. So what happens when I go backwards? So if you look at this, it's a pattern. It's a complete pattern. What happens when you go backwards is it becomes smaller. 1/5 times 5 is 1. And 1 times 5 is 5. So you just keep going, times 5, times 5, times 5, times 5. So if I went back even farther, 5 to the negative 7, or second, it would be 1 over 25. And I can keep going. 5 to the negative 3 is 1 over 125. And then if I look, it's a complete pattern. All the exponents are a pattern where you're multiplying by 5, the next one just gets multiplied by 5, and you can go on forever in both directions. So a negative exponent is just becomes a fraction. So make sure you put that in your notes. So simplifying a power. So if I asked you to simplify 4 to the negative third, okay, you would say, okay, that's 1 over 4 to the third, and that's 1 over 64. That is simplified. This is not simplified, okay? This is. So you want to make sure that you actually multiply it out. Negative 1.23 to the 0 power is 1. So that's pretty simple. So try A, B, C, and D. And you may use a calculator. So this would be 1 over 3 to the 4th, which if I take out my calculator, 3 to the 4th power is 81. So 1 over 81. This equals 1. That's nice. It's so easy. So now this one, negative 4 to the negative 3rd power. So now when I do this, I'm going to have 1 over negative 4 to the 3rd, and that's in parentheses. So now I'm going to do negative 4 3 times. So negative 4 to the 3rd power is 1 over negative 64. Because if I wrote this out, it would be negative 4 times negative 4 times negative 4. If you remember, if the negative's inside the parentheses, it gets included. If it was outside the parentheses, then you would just add it on after. And since it's the 3rd power, that's an odd number, so then it would just be that. 1 over negative 64. Now 7 to the negative 1 is 1 over 7 to the 1st power, which is just 1/7. Okay, simplify each expression. So now, what they're going to do is they're going to combine a number and some letters and some negative exponents, positive and negative exponents together. What you need to realize is, oh, x to the negative 3 only goes with x. It doesn't go with the y and it doesn't go with the 4. It's completely separate. So they put it in red, which I kind of like. It kind of makes sense. And then you can see, okay, 4y just stays the same, and then x to the negative third becomes 1 over x to the third. So then you can write it as 4y over x to the third. 1 over w to the negative 4 is 1 divided by w to the negative 4, which if I wrote w to the negative 4 out, it would be 1 over w to the 4. And then when you divide, you can multiply by its reciprocal, so it would just be w to the 4th power. So try A, B, and C. So this is 11, whoa, not m yet, 11, and then m to the negative 5th is separate. Those go together, so that would be 1 over m to the 5th. So this would be 11 over m to the 5th power. This I have 7, and then I have s to the negative 4, which is 1 over s to the 4, and then I have t squared. So if I combine all of this, I would get 7t squared. That all goes on the top, and then s to the 4th power is my denominator. And then this last one, I have 2 divided by a to the negative 3rd, which is 2 divided by 1 over a to the 3rd, which if I multiply by the reciprocal, I can multiply by a to the 3rd over 1. And so my answer is 2a to the 3rd. So evaluating, now they're going to give you this crazy expression. Sorry, dropped my calculator. They're going to give you this crazy expression, and then they're going to ask you to evaluate it for numbers. So if you look at this one, this first one, 3m squared t to the negative 2. Well, first they decided I'm going to get that t to the negative 2 and put it down. So then once I get my, now I'm all positive exponents, then I'm going to plug in my numbers and find my answer. So the same thing here is they got this negative 2 and then they put it down in the denominator and then they put in their numbers and found their answer. It's kind of, those are both the same problem. They're just showing you different ways to do it. So try these problems, A, B, C, and D, and then we'll correct. Okay, so n to the negative 3rd would be 1 over n to the 3rd times w to the 0 is 1. So really I just need to do 1 over n to the 3rd, which is 1 over negative 2 to the 3rd power. So 2 times 2 is 4, times 2 is 8. So that would be 1 over negative 8. Ooh, I'm getting into my other problem here. N to the negative 1 would mean it would go on the bottom. That would be 1 over n to the 1. And then I have w to the 2nd. So if I rewrote it, it would look like this. So then I'm going to have 1 over n is negative 2 times 5 squared. So 1 over 5 squared, I have to do that first, so it would be negative 2 times 25. And then so I get 1 over negative 50. Next I have w to the 0 power is 1. So this would be 1 over n to the 4th, which is negative 2. So 1 over negative 2 to the 4th power. So negative 2 4 times is negative 2 times negative 2 is 4 times 4 is 16. So 1 over 16. This I have 1 over n, and then I have w to the negative 2nd on the bottom. So it would kind of look like this. Well, if I flip this around, the w to the 2nd would go on the top. So w to the 2nd over n. So then w to the 2nd is 25 over n, which is negative 2. So that would be negative 12.5. Okay, a biologist is studying green peach apids, like the one shown at the left. I didn't copy the picture, sorry. In the lab, the production doubles every week. The expression 1,000 times 2 to the W power models an initial population of 1,000 insects after W weeks of growth. So evaluate the expression for W to the 0 power. So if you just look at this, what do you think that means? Okay, what that means is they are starting with 1,000 insects and they are going to double it. So the 1,000 is the starting point and this is the growth rate. So the doubling would be the 2. And then after 1 week, after 2 weeks, after 3 weeks, it's going to double every single time. So W equals 0, you're just going to put 0 in and it's 1,000. So that's what you're starting with at the beginning where 0 weeks have passed, it's 0. So then it says evaluate the expression for W is -3. Then describe what the value of this expression means. So 2 to the -3 is 1/8, so that's 125. So that means there were 125 3 weeks before the population of 1,000. So 3 weeks earlier, there was 125. So try this one. A sample of bacteria triples each month. The expression 5,400 times 3 to the m power models a population of 5,400 bacteria after m months of growth. Evaluate the expression for m equals -2 and m is 0. Describe what each of them means. So if I have 5,400 times 3 to the -2nd power, and then I have 5,400 times 3 to the 0. This is 5,400 times 3 squared, which is 1/9, because it would be 1 over 3 to the 2nd power, which is 1/9. So 5,400 times 1/9 equals 600. And this is just 5,400 times 1, which is 5,400. So this one is 2 weeks before, and this is at the start. This is how much you had at the start of your experiment. And that's it for your notes.